In the lesson today, you're going to have more practice factoring linear expressions. We talked yesterday about factors. Factors are two numbers that are multiplied together to form a product. But if they want you to factor something, that means to write a number or an algebraic expression as a product. And that's what we practiced yesterday. It's going to be what we practice again here today. We're going to have some numbers and some linear expressions, and then we're going to rewrite them as a product. And also remember, the greatest common factor, called the GCF, is the largest number that's a factor of two or more numbers. And so on the first problem here, I've got three different sets of numbers. For each set of number, I'm going to find their greatest common factor. And I'm going to use a method that you may have seen in the past. You might call it the ladder method. I like to call it the factor box method. But I'm going to go ahead and put a kind of like an upside down division box around my two numbers. Then I'm going to think of any number that would be a factor of both 12 and 16 in this case. And I know both of these numbers are even, so I know that 2 is a factor. So I'm going to put the 2 on the outside here. And then what I'm going to do, I'm going to divide each of my numbers by 2. 12 divided by 2 is 6, and 16 divided by 2 is 8. Okay, so they shared 2 as a common factor, and now I'm going to start over with 6 and 8 and see if they have any other common factors. So let me put a box around the 6 and the 8. And looking at those numbers again, I realize that they're both even, so they're both divisible by 2, so I'll put my 2 on the outside. 6 divided by 2 is 3. 8 divided by 2 is 4. So they had 2 as a common factor again. And now I'll put a box around 3 and 4 and see if they have any common factors. And looking at 3 and 4, you might think that they don't have any factors in common, but they really do. They actually have the number 1 as a common factor. Now, when you divide these numbers by 1, nothing's going to happen, which indicates to me that I found all of their common factors. And so now what I need to do is figure out what the greatest common factor is, and I'm going to do that by using these numbers on the outside. What I'm going to do with these numbers, all right, you might think that you have to add those numbers, but if I add them up, 2 plus 2 is 4 plus 1 is 5. 5 is not a factor of 12 or 16. Instead, what you need to do is take the numbers that are on the outside and you need to multiply them together. 2 times 2 is 4. 4 times 1 is 4. So the greatest common factor of 12 and 16 is going to be 4. Repeating this process now for 27 and 36, I'm going to go ahead and put my factor box around those. And again, I'm going to think of any number that goes into 27 and 36. And I know that 3 would go into both of these numbers, so let me put my 3 on the outside. 27 divided by 3 is 9, and 36 divided by 3 is equal to 12. Okay, now I'm going to start this process over again with 9 and 12. 9 and 12 again are each divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. And now I'll put my factor box around the 3 and the 4. And this actually matches what we had over here. The only common factor was 1. And so I know I found all of the common factors. And so if I multiply these numbers together, 3 times 3 is 9. 9 times 1 is 9. That's going to become the greatest common factor. Okay, so let's see if we can find a GCF for 42 and 105. Okay, and so looking at my numbers here, okay, well, I know that each of these numbers is divisible by 3. Okay, so if I go ahead and divide by 3, 42 divided by 3 is going to be 14. 105 divided by 3 is going to be 35. And so now I'm going to repeat this process for 14 and for 35. I know that both of these numbers are divisible by 7. All right, 7 goes into 14 twice. 7 goes into 35 5 times. And now I'll repeat the process for 2 and for 5. And the only factor that 2 and 5 have in common is 1. So I know that I found all the common factors. So if I multiply these numbers, that's going to give me the GCF. 3 times 7 is 21 times 1 is 21. And that is going to be the greatest common factor. So our big goal for today is to be able to find the greatest common factor of terms in a linear expression in order to help us factor. And so just like I did up above, I've got this expression 4x plus 12. I'm going to treat each term individually, and I'm going to put a factor box around the entire thing. I'm going to look at each term and see if I can figure out what they would share as a common factor. And looking at both of these terms, 4x and 12, I can see that 4 is going to be a common factor. So I'm going to divide each part of the term, or the expression rather, by 4. 4x divided by 4 is just going to be 1x, and 12 divided by 4 is going to be a positive 3. So that's going to leave me with 1x plus 3. And now I'll go ahead and figure out if 1x and 3 have a common factor. And the only common factor that 1x and 3 share is the number 1. So 1x divided by 1 is still 1x, 3 divided by 1 is still 3, and so now I see that I've got my common factors factored out here. If I multiply these numbers on the outside, that's going to give me my GCF. 4 times 1 is 4. And so that's going to become one of the terms, one of the factors in my answer here. And the other one is going to be what was left over when we couldn't factor any further, 1x plus 3. So if I multiply 4 by 1x plus 3, that's going to give me 4x plus 12. So I'm going to put the rest of that, 1x plus 3, inside of parentheses. And again, a good way to figure out if you've done this correctly is to just use the distributive property, distribute back as a check. If I did 4 times 1x, that would give me the 4x, and if I did 4 times 3, that would give me the 12. And so what I've done here is factor the expression completely. 4x plus 12 is the same as 4 times, in parentheses, 1x plus 3. In example B, put your factor box around 18b plus 20, and let's see what they have as a common factor. I know that 18 and 20 are both even, so I'll use 2. 18b divided by 2 is 9b. 20 divided by 2 is positive 10. And now I'll put my factor box around 9b plus 10. Their only common factor, however, is only going to be 1, and so that's going to keep me with 9b plus 10. I multiply 2 by 1, which is 2. That's the greatest common factor. And then the other factor of the expression is going to be what was left over, which was 9b plus 10. And again, if you distribute as a check, 2 times 9b is 18b, 2 times 10 is 20, so I know I factored correctly. In example C, we have 12a minus 18b. I'll use my factor box here. All right, and again, I look at my numbers and I realize that they're both even, so I can divide them by 2. 12a divided by 2 is 6a. Negative 18b divided by 2 is negative 9b. Now I'll use my factor box with 6a minus 9b, and I can see that 3 would go into both of those. 6a divided by 3 is 2a. Negative 9b divided by 3 is negative 3b. Put your factor box around 2a plus 3b. 1 is their only common factor, so that's going to leave us with 2a minus 3b. And now when we multiply for the GCF, 2 times 3 is 6 times 1 is still 6. So our first factor is 6, and the other factor is going to be 2a minus 3b. In the box for question 4, they've asked us to factor 12x plus 7y. So if you put your factor box around those two terms, all right, and you look at them, well, it's tough to figure out if they have anything in common. In fact, they really don't have anything in common except for the number 1. And again, that's not going to change anything. That's going to keep 12x plus 7y. So 12x plus 7y is really just 1 times 12x plus 7y. And when the GCF of two terms is 1, like in this example here, the terms are called relatively prime. These are relatively prime terms, meaning that their only common factor was 1. In example 5, we've got a couple of different expressions to look at. Our first one is 6n plus 15mn. I'm going to go ahead and put my factor box around 6n plus 15mn, and I'm going to look for a common factor. And looking at my numbers, I see that 3 would go into both of those, so I'll divide each of them by 3. 6n divided by 3 is 2n. Positive 15mn divided by 3 is positive 5mn. And now I'll put my factor box around 2n plus 5mn. And looking at these two terms, well, with the numbers 2 and 5, their only common factor is 1. But if I look carefully at my two terms, I realize that each of them has an n as a common factor. And so I can even divide out variables as long as each term has that variable in common. Okay, so I'm going to divide 2n by n. 2n divided by n is just going to leave me with 2. 5mn divided by n is going to leave me with a positive 5m. Okay, so if your terms have a variable in common, you can factor that variable out just like you would be able to factor out a number. Okay, put your factor box around 2 plus 5m. And again, now these terms only have 1 as a common factor, which will leave us with 2 plus 5m. And so we're going to multiply on the outside to get the GCF. 3 times n is 3n. 3n times 1 is still 3n, so that's going to be our first factor. Times, in parentheses, what was left over, which was 2 plus 5m. In the next example, same thing here. I'm going to put my factor box around the two terms, 12CD minus 15C. And I'll start by looking for a numerical factor. I see that 3 goes into each of those. 12CD divided by 3 is 4CD. Negative 15C divided by 3 is negative 5C. Put your factor box around 4CD minus 5C. And I notice that they have the variable c in common, so I can factor that out. 4CD divided by c is 4d. Negative 5c divided by c is just negative 5. When we put our factor box around 4d minus 5, we should realize that they only have a common factor left over of 1, which will leave us with 4d minus 5. And when we multiply for the GCF, 3 times c is 3c, times 1 is 3c. So that's our first factor, 3c. Our second factor is going to be what was left over, 4d minus 5. And now 12CD minus 15C in factored form is 3C times 4D minus 5. On the last page, we have lots of practice examples, and I definitely encourage you to do all of them. It's really good practice. I'm only going to put a few on the Play Pause It for you to answer, but you can also go to my website and check to see how you did on the other ones. So put your factor box around the two terms and look to see what numbers do they have in common, but also do they have any variables in common. Make sure that you factor each expression completely.